So, 안녕하세요. 저는 강윤서입니다. I'm a co-founder of Open Tech Forever and a 2012 Field Fellow. Improving human communication, capability, and collaboration sets the foundation for collective empowerment in today's society. But such collaboration calls for a new set of social promises to uphold for the 21st century. Open source is a promise that sharing our knowledge, skills, and technologies will benefit all of us more than keeping secrets ever will. A promising strategy of maximizing humanity's potential and capacity to innovate and create value. Already we've seen how open source software provides users and developers the digital tools and resources they need to succeed. Now we're seeing the dawn of open source hardware, the promise to empower everyone with the information required to make tangible innovation and entrepreneurship easy. Businesses and organizations are just beginning to adopt open hardware practices, but some concerns persist. The high cost of tangible technologies, the realistic potential of learning resources for hardware, the effects of opening proprietary technologies for the competition, and the bottom line. Open source hardware is clearly the future for achieving humanity's potential. The real challenge is to create a smooth transition from the current economic context. This is my story. I was born here in Seoul in '93 and moved to Canada at the turn of the century. While learning things in school as a child, I started using a computer and, yes, I'm feeling lucky, and oh, that's a cool video. And before I knew it, I was obsessed with battle robotics. Robotics was cool and engaging, and along the way I picked up some basic mechanical and electrical engineering skills. After scouring hundreds of online guides, stores, and forums, it wasn't long before I started making robots at home and school. I appreciated the free online resources that made basic robotics possible for me. And what I learned with that experience shaped my life. But I had more exploring to do. In 2008, the panic amid the global recession focused my study in economics. Beyond the abstractions of economic theory, I learned about the reality inside the economy. How individuals, communities, businesses, governments interact was really about how people go to school, find and work at jobs, run businesses, pay taxes and receive benefits, and live day-to-day lives amid the backdrop of all the world's problems. Everyday people, unable or struggling to afford necessities, crises that concern humanity, people whose lives and rights are abused, denied, and destroyed in various ways around the world. And there I realized life wasn't just about doing cool and engaging robotics anymore. This was the real world, with real people whose real futures are shaped by all of our actions, including our own. So I began to ponder, what could I do to make things better? Out of all possible futures we can create together, which do we want to make reality? It was clear that information was a big part of the solution because knowledge illuminates uncertainty and becomes a powerful activator of possible futures. Greater access to relevant information for everyone can lead to a possible future of flourishing innovation and sustainable economic prosperity. Sharing our knowledge freely online on websites like Wikipedia was a key step in the direction. But it wasn't enough. The shared knowledge had to integrate into the world, be more relevant to our lives, to provide straightforward opportunities for innovation and value creation. Open source software was the beginning of this next step. Sharing programs, code, and insights provide users and developers the real tools and resources required to succeed on their projects and innovate furthermore in the field of software. Open source hardware was clearly the next step, and after seeing Marchin's TED Talk on open source blueprints for civilization, I took a big risk. After graduating high school, I gave up going to university and instead went down to Missouri in the US to work with Martin on the open source ecology project. My parents were upset, friends found it interesting, but I knew this was an opportunity that couldn't wait. High risk, but I had my hobbyist technical skills to back me up. And thus ensued a wild year of making new friends, doing open source mechanical and electrical engineering, fabrication and automated manufacturing, off-grid system development, industrial machine and vehicle operation, and more. During my time there, it became clear that open source hardware had to be more than sharing design files and hard design information. The documentation also had to explain all the tools and materials required to make a technology and show where to get them. What skills and techniques and how to train them, what basics and introductions and where to learn them, how to find and communicate with the people who need the hardware. All of this information conveyed using the best of modern digital tools to complement by projects and activities for improved skill development and retention. After I left Open Source Ecology, I co-founded Open Tech Forever, an open source hardware cooperative with our story yet to unfold, just beginning our open collaboration for our R&D and processes. That's my story so far. Now imagine if all hardware technologies in the world had all their information freely and openly available in the best form using modern digital tools. All the designs, design considerations, manufacturing techniques, supplier information, and more. From open agriculture to construction, energy and telecom, semiconductors and advanced materials and beyond. Greater access to hardware information empowers individuals and groups to easily start and improve businesses. DIY and sharing projects become easier to do for saving costs, helping each other, and learning new things in the process. Access to quality education for modern and cutting-edge industries expands its frontier outside the confines of company developers, training programs, and databases. And notably, innovation gains the benefits of collaborative development, where we can build upon each other's work and learn from each other's mistakes. You can help. As an individual, group, community, business, government, be more transparent and share your information online and offline. At the least, be more available and receptive to those looking for particular information about what you do. We stand to gain so much from open source software, open source hardware, and open source business model, triple combination, super duper economy education booster. Let's develop and collaborate openly towards a crucial key for civilization's progress in the 21st century, the open source economy. 감사합니다. Now please welcome Marcin and Katarina.
Welcome. Hi, my name is Marcin, founder of Open Source Ecology.
I'm Katerina from the Open Source Hardware Association.
Okay, so today we'll talk about a new breed of industrialists and the revolution they have set in motion. But before we go there, we'll go back to the first industrial revolution and two events that have changed the course of the world. So in 1777, James Watt began selling his new steam engine. It was twice the efficiency of anything before in the market, a major breakthrough at the time. And he patented his invention and protected his patent fiercely. So about 30 years later after that, another man named Richard Trevithick took his new design to market, and in his case, he did not patent his invention. So the miners, the tin miners in the county of Cornwall in England were really glad to see this, as they had problems with James Watt's design, trying to maintain it. So they started to innovate on an open design and make improvements as time went on. And a very interesting thing happened. So here we have a graph of the efficiencies, the gains in efficiency, both in James Watt's time and in Trevithick's time. And in James Watt, the efficiency rose about 4% per year in his time, compared to more than twice that, about 9% in Trevithick's time. So the other point to remember there is that the number of patents that the Cornish miners took out at that time was just 15 compared to almost 1,000 by James Watt and company. So we've seen that the number of patents was inversely proportional to the rate of innovation. So we might ask the question, was that high rate of patenting also responsible for decreasing the rate of innovation? Well, the historical evidence, if we look more deeply into this problem, it appears that that was indeed the case.
So several decades later, Henry Ford was ready to begin production on a brand new car model. Up until then, cars had been expensive machines only the wealthy could afford. But Ford's new model cost half the price of the average car at the time, and he called it a car for the common man. However, in order to begin production, Ford needed the approval of the Association of Automobile Manufacturers. The association held the patent for the automobile, and no one was allowed to produce one without their approval. So Ford requested permission and was denied. He began producing his cars anyway and was in turn sued for royalties. The court sided with him and ended the monopoly for the automobile. The result was a boom in the car industry. Ford's company was one of the first in the city of Detroit in the United States, but within 2 years, more than 100 car manufacturers had appeared. So Ford's low-cost model made it accessible to a whole new market segment, and everybody wanted one. His cars were bought by traveling salesmen, by artisans, by farmers, people who had never dreamed of being able to afford a car. In fact, the car became so popular that Ford couldn't keep up with demand. He also wanted to make it cheaper, and back then, the way to make cheaper goods was to produce more of them in less time. So Ford began streamlining the assembly line. Under the old production model, it took over 21 hours to assemble a car. With the new assembly line, it took only 1 hour and a half. So both of these stories are about making technologies available to a greater number of people and the wave of innovation that follows. They're about the extraordinary things that happen when monopolies are broken and people are given the freedom and conditions to unleash their productivity. However, even though the assembly line brought us the 8-hour workday and cheaper products, it also brought about the age of mass production. And with it, one size fits all and the consumer society. Artisan and small-scale production simply weren't cost efficient. And because of that, manufacturing became the realm of professionals and large corporations. But now we're on the brink of a new industrial revolution. This is a transformation that both repeats and inverts these events of the past. It hinges on the democratization of some very powerful technologies that may very well disrupt manufacturing as we know it and transform entire economies, but also on a very old and very new way to produce, the collaborative economy.
Okay. So the internet has changed the way in which we communicate, work, and play, and new business models are rising on top of that. Things such as Airbnb, which is right now, well, it allows people to rent houses and rooms directly to one another. It's a $1.5 billion market worldwide and $56 million in the city of San Francisco alone. Services like TaskRabbit, which allow us to hire others directly without a middleman for all kinds of tasks. And this is used by some people as their full-time job even. And then there are services like Kickstarter, crowdfunding platform which allows people to give money to projects directly without people getting loans from banks, and that's providing $100 million of project funding to different people around the world. So this is part of a mechanism where we're getting into working directly with one another, skipping the middleman, and building enterprises upon these peer-to-peer networks in a way that was not ever before possible. So what's become known as the sharing economy has become almost a $4 billion a year market. So the same technology that's used to generate these new economic models and to consume together can also be used to create and design together. So just like the Cornish miners began exchanging information and publishing in a journal, now we can have that same opportunity to collaborate, but on a much broader scale. So a huge part of this is the concept of open source hardware. And that is a research and development method for product development in which people publish their designs openly, they share them so that anyone can download them, play with them, change them, and use them for their own ends. Now, just to show you, here's how it works. So you've got, say somebody comes up with an idea, say for a bicycle. Then you prototype it, you build it, put the plans online, then others can copy them, build an exact replica from those plans. Or someone can take those plans and modify them for their own tastes or for improvements. Or you can manufacture them and sell them at a profit. Now, these improvements typically want to go back into a common pool of knowledge such that those are absorbed back into the design, and a cyclical pattern of improvement, of building on top of former work occurs. So this allows us to get away from reinventing the wheel and truly build upon each other's work.
However, a powerful means to share information in open source plans wouldn't be very significant if we couldn't actually manufacture them. Up until a few years ago, we had a choice between two types of tools: mass production tools and manual tools, nothing in between. Things began to change in the 1980s with the maturation of digital fabrication tools: 3D printers, laser cutters, CNC mills, machines that produce physical objects from digital designs. What is interesting about these technologies is their flexibility. While it takes a conventional factory months to switch from the production of one good to another, with digital fabrication tools we can make toys in the morning and chairs in the afternoon. And for the same reason, the cost of producing one single item is not very different from the cost of producing 100. But if these technologies have been around for 3 decades, why haven't we seen more of them sooner? Well, just like the mainframes of the pre-personal computer days, digital fabrication tools were at first extremely expensive, accessible only to large organizations and used mostly for prototyping. In 2004, Adrian Boyer, a professor in the UK, decided it was time to make digital fabrication accessible to the common man. So he began designing a compact and highly affordable 3D printer capable of manufacturing several of its own parts and all sorts of plastic objects. He named it RapRap and released it as open source. With the plans available online, hobbyists around the world began making self-replicating devices in their basements and using them to make parts to make more machines. And a few short years after that, Adam Mayer, Zach Hokan, and Brie Pattis simplified Adrian's design and created another highly affordable machine based on it. Their model cost $850 at the time when the cheapest commercially available 3D printer cost over $15,000. So excited with the results, they quit their jobs and with barely any initial investment, launched a company to sell their 3D printer as kits. They are now one of the most successful manufacturers of personal 3D printers. And after that, the desktop 3D printer market, which didn't exist until then, exploded. 3D printers were just the beginning. Soon, open source laser cutters and CNC mills appeared as well. LaserSaw, the laser cutter pictured here, cost $7,000 compared to $30,000 for the proprietary ones. So RapRap, MakerBot, LaserSaw launched the wave of change that is beginning to put production in the hands of the common man. And this combination of open source plans with access to fabrication tools is giving rise to a new breed of industry, the open source industry. So who are these open source industrialists who believe in the power of collaboration and are building businesses on top of it? They are the makers of cars like Locomotives and Wikispeed, with their 100 mile per gallon 5-star crash rating car. They are the makers of houses like WikiHouse and Architecture for Humanity, the makers of aerial drones like DIY drones, of oil spill cleanup drones like Prote, and of subaquatic drones like OpenROV. They're the makers of toys like Littlebits, and the makers of construction and agriculture machinery like open source Ecology.
Okay. As founder of open source Ecology, I'd like to share my story on that. So, at Open Source Ecology, we've identified the 50 most important machines that we think it takes for modern life to exist. The things we rely on every day, whether we know it or not, things like tractors, ovens, circuit makers. Then we create an open source, do-it-yourself version that anyone can build and maintain at a fraction of the cost. We call this the Global Village Construction Set. So, are we reinventing the wheel here? Well, yes. So let me tell you a story. So I finished my 20s with a PhD in fusion energy, and I discovered that I was useless. I had no practical skills. The world presented me with options, and I took them. I guess you can call it the consumer lifestyle. So I started a farm in Missouri and learned about the economics of farming. I bought a tractor, then it broke. I paid to get it repaired. Then it broke again. And pretty soon, I was broke too. So what I realized was that the truly appropriate low-cost tools that I needed to build a sustainable farm and settlement just didn't exist yet. I realized I would have to build them myself. So I did just that. And I tested them. And what I found out was that industrial productivity can be achieved on a small scale. So then I published the 3D designs, instructionals, schematics, and budgets on a wiki. Then contributors from all over the world began showing up, prototyping new machines during dedicated project visits. So far we've prototyped 15 of the 50 machines, and the project is taking off on its own. People have downloaded our open source plans, and now there's over a dozen replications in 5 countries around the world. So the next step is to demonstrate that each one of these machines can be built in a single day of production in a basic fabrication shop.
It may seem strange that industrialists are giving away the plans for their products, but that's exactly what's happening. It is happening because it's a better research and development method. With the plans available online, anyone, including their competitors and customers, is free to customize and improve them. In turn, these improvements become public and everyone benefits, leading to faster development and more appropriate technologies all around. So the same collaborative approach that worked for the Cornish steam engine is now fueling the open source industry. But how do they stay in business if they give away their designs? Well, the answer is deceptively simple. They make things and then they sell them. And then they stay ahead of the competition, not by holding a monopoly, but by offering the best products and services at the best prices. And they are becoming very good at it, with companies such as SparkFun, a producer of open source electronics with 140 employees and their own production facilities, reporting revenues of over $75 million for 2012. At the turn of the 19th century, the Cornish miners demonstrated the power of open collaboration. However, despite this early warning that patents may not be as beneficial to invention as initially thought, the number of patents continues to grow. And now, just like the Cornish miners did 200 years ago, we are again questioning the role of intellectual property. In recent years, respected jurists and economists alike have come to the public's attention with concerns that the current intellectual property system may in fact be stalling economic growth and hindering innovation. Is it useful that in this day and age, spending by Google and Apple on patents exceeded spending on new products, development of new products?
So efficiency and automation are even more important today than they were 200 years ago. And the good news is that we have a lot of those tools available to us. So lower barriers to production, better means, better access to the digital fabrication tools means that we can create more sophisticated businesses on a small scale. So here's an example of a car company for electric cars. This is Tesla Motors with their army of industrial robots. Now that's not open source, but the point is that Tesla Motors can do, say, 100 cars of production per week, as opposed to like 10,000 per day for a standard assembly line. And in open source ecology, we're pushing the limits of this even further in that we've built one of our machines, the automated compressed earth brick press, in a single day of production. So how does that work? We took 10 people and people who might have not even met each other and people who have never built something like remotely like a construction machine before, but with our open collaboration methods, including the open design, including IKEA-style fabrication diagrams, and open blueprints, of course, and access to a CNC laser cutter that allowed a single person to cut out all the parts readily and accurately. So this is an example of the kind of promise where if this model is truly working, then we can talk about production efficiencies of design such that this may indeed become a model, a preferred model of production, of design for standard companies. So one day may not seem like much compared to the millions from mass production, but the idea is that thousands of such microfactories can become the new engine of production in today's world. That's the whole promise of Industry 2.0, the concept of globally sourced, globally collaborative design and locally adapted digital flexible fabrication.
So mass production became desirable because churning out thousands of identical items lowered the cost of production significantly. But if we can now have cost-efficient, small-scale production, then the appeal of the one-size-fits-all for consumers is considerably decreased. Another interesting effect of this convergence of democratizing technologies with new models for collaboration lies in the distribution channels. While a century ago small-scale production was confined to local markets, nowadays the Internet allows producers at all scales to distribute worldwide. This is what Chris Anderson calls the long tail. As the cost of reaching consumers drops dramatically, our markets are shifting from a one-size-fits-all model of mass appeal to one of unlimited variety for unique tastes. This has been shown from DVDs on Netflix, to songs on iTunes, to advertising on Google. And the same applies to physical goods. This is not just a property of digital marketplaces, it's a new business model that is only beginning to show its power. So we envision a global supply chain made up of thousands of small producers, manufacturing quality goods they are proud of, distributing them locally and globally, and collaborating with each other to create better, faster, and more meaningfully. Enter the economy of meaning. What happens when people gain access to tools that make them more capable, powerful, and productive than ever before? Can anyone make anything anywhere? Can we accelerate innovation to solve problems faster than they are created? The long tail is really about the economics of abundance.
Yeah, so in the overall scope of human progress or innovation, it may be said that we have mastered production. And the next phase is to master distribution. If we can achieve that, the new economy will begin to revolve around different questions about what are our deepest motivations and desires, and then how does the new economy give us the means to achieve them? It will be an interesting point when we transition from mass jobs to mass meaning. I like Daniel Pink's comment on this in his TED Talk about the surprising science of motivation, in which he talked about that people are not really motivated by a bigger reward, that the real intrinsic motivation comes from three basic values, and that is autonomy, mastery, and purpose. Autonomy is the urge to direct our own lives. Mastery is a desire to get better and better at something that matters. And purpose, the tendency of us to do what we do in service of something greater than ourselves. So as our economy becomes more and more sophisticated, these three properties now become the new driver of the economic system, and therefore of the world. So I challenge you to collaborate, to open up your know-how, share, and do that bravely, and possibly no fear in that. So the rewards are huge. It's about the opportunity to reintegrate communities, to rebuild economies, to disrupt manufacturing, to regain ecology, and to unleash productivity everywhere and leapfrog through old problems while leaving nobody behind. Okay, thank you. Okay. So thank you for listening. Now we're going to get Yunso back on stage, the three of us, and we're going to have a session on dispelling the myths of open source. There's a lot of different questions about the topic that people have misconceptions about. So we're going to go through a few of them right now in our session about dispelling the myths. So, okay. So, first of all, there's a lot of thought that people keep associating open source with the inability to make money, but is that really the case? Is there a way to make money in open source? Who here thinks we can make money from open source? Maybe a few. Okay. Well, what are your thoughts, guys?
So I think it's good to categorize it down to development and production. And the traditional way to do this is you can develop open source hardware, share the information, yet still be able to coordinate the production of it and distribution so that you can make money from that side, the production and distribution. And then the flip side of things is you can still fund the development of open source hardware by, for instance, crowdfunding the development process. So I guess those two are some of the processes.
Yeah, so definitely we can sell the real product, selling the atoms that we produce, even though the plans are open. There's nothing preventing you from using that as one of the oldest business models of producing goods. Anything to add, Katarina?
I mean, open source hardware is not per se a business model. It's a research and development model. And then people build, usually build very traditional businesses on top of that. And there's been some around, like there's this one, the company we mentioned earlier, SparkFun, has been around for 10 years, 140 employees. They're doing very, very well. Everything they produce is open source. There are several other companies also been around for several years and are doing very well. Of course, this is just the beginning. We haven't covered like all markets yet, nor all types of products. So we're testing the model, we're pushing it to the limits. But so far, so good. No company has actually closed or tanked because they're open source. That has not happened.
Right, and the share of the open source hardware market is extremely small. It's like, what is it, like a millionth or something of the entire economy today. But we'll see what happens. See what happens. And the distinction has to be made between open source hardware as a development method versus the revenue generation method, which is a separate side of the equation. Okay, so let's go to the next one. So openness is bad for your business because cloning by copycats will run you out of business. All right, what's to be said about that?
Inso, do you want to go first?
Cloning, okay, cloning. That seems to happen everywhere.
Okay, so I would say two things about this. One is cloning is not an open source problem. The iPad is not open source. The iPhone is not open source, but there isn't one seed in the world where we can't get a bootleg version of the iPad or the iPhone. Everything worthwhile cloning will be cloned. The only things that are not clones are the really, really bad products no one wants. There are companies now I think there's some in China, there's some in the West that will reverse engineer a board for $1,000 in 48 hours. So, I mean, the cost and the access are just unprecedented.
Okay, so copying can be done. There's a lot of reverse engineering capacity. So what happens when you have a product and then someone just sells it for cheaper? Any solution to that?
So far that has worked out very well for the open source products. All the products that were cloned actually gained with that. Arduino, which is a microcontroller, a few years ago they realized that there was a company in, I forget where, but a company in, outside the States that was copying their boards and selling them, but their own sales were also increasing. And what happened is that this company, I think they were in Thailand, actually brought their product to an entirely new market, a market they would not have had access themselves. So basically they just expanded the market.
Okay. So cloning could also be a marketing method in some way.
Yeah.
Well, also our personal story with open source Ecology, we've sold a number of our machines, like for example in a production run back in 2011 we cleared $25,000, and when anyone replicates our machines, it's actually good for us because the popularity of them spreads, there's more feedback coming on the actual use of the machines and all that. So for us it seems to work out because the people who end up cloning us or copying it, we encourage that first of all, because typically that brings information and new designs back to the community. That's been our experience with that.
I would also add that through the openness, it brings out a need for transformation of consumer culture towards trust and integrity of organizations that consumers can have as the higher focus, so that even if there are replicators or cloning by copycats, you still have trust and transparency within organizations who are doing R&D and have shown good track records and such, that consumers can still stick onto. It's very similar to the brand loyalty we can see today.
I just want to, okay, do you have time?
Yeah.
Just so, yeah, like tying out into use and say like the importance of brand. Brand is, you know, is as important, or even more important in open source in general. For example, the fashion industry has no IP protection other than trademark. Right, so they're a very good case of what open source is. Like fashion is de facto open source, and it's not dying. You know, there's a lot of companies in the fashion industry that are growing, and they bet everything they have in fast innovation. That's why they provide us with 2 collections a year at least, and brand. I remember a few years ago, there was this article about Chanel and the knockoff Chanels, and the person who buys a real Chanel is not the person that buys a knockoff, and the same thing happens with open source products.
Okay, so there's a case that cloning will allow open source to survive. Okay, so next one. So patents promote innovation. Any comments about that? So we've talked about the inverse proportionality in the case of the steam engine back about 200 years ago. So that seems to point opposite to this point. What other evidence has been there in history? Do we have any real examples where patents actually do promote innovation?
So we have the case where patents, traditionally we've seen, allow companies to protect certain lines of products such that they can gain the financial sustainability, the profits to put back into R&D, and of course that would be a case where patents did in fact encourage innovation through the sheer funding of R&D.
So that might be a different approach. Yeah. How about Katerina?
I mean, one case that has been said for which patents are really, really important, and you know, it might be the case, I don't know enough about it, is in the biomedical field, because the investment is so big and it takes so many years to develop a new drug that it would be very, very hard to convince pharmaceutical companies to actually make this investment if they didn't actually hold the IP for at least 20 years. So that's probably the one case that I can think of in which patents are really important. But now, if you transfer that to technology, it starts to not make a lot of sense, right? Because a patent, for example, like it's in the US and Europe is around 20 years. And the idea when they were created was like, we will give you, we as the state, the government, whatever, a community, right, a country, we give you 20 years of this monopoly in exchange for you letting us use it after 20 years. But what technology is it worthwhile to use after 20 years nowadays? This made sense 200 years ago, but nowadays things change so fast that a 20-year technology is not worth very much.
Mm-hmm. Yeah, well, patents came out for the purpose of increasing innovation initially when they were first designed, and whether that's still the case, that's debatable, but there's evidence for and against that. All right, so let's move on to the next one. So open source and patents cannot go together. All right, open source, well, I have a comment on this. So patents, there's actually a thing called a defensive patent within the open source community, where people patent something so that someone else cannot close up that technology, thereby protecting. So if the patent is taken out for the purpose of keeping it open source, that's an actual way to protect open source. So these are some of the latest debates in the open source community that are happening, but that's one case where patents can be used for the purpose of open sourcing. So what else do we know about this?
I guess it really depends on the meaning we apply to patents, because patents we could apply as, is it legal to replicate for further R&D, or is it just that specific patent restricting the development only in the commercial field? Or maybe it's dependent with royalties. So a lot of the open source versus patent combination have to do with what kind of meaning, what kind of legal meaning we assign to patents, whereas open source, of course, is openly sharing information.
Mm-hmm. So the details of the patent itself, like what exactly is being covered or what are the terms of use of that patent, would matter. And you can use it to perhaps stifle innovation or actually increase the open source nature of something. So there's two different ways. Anything to add, Katarina?
I just want to add that it's not directly the case with patents, but there is a correlation between open source licenses and Creative Commons licenses and the intellectual property system. For example, the way it works is each one of us, just by the act of creating and putting something out there, even if it's just a sketch on a napkin that you leave in a restaurant, you have copyright over that drawing, like whether you meant to or not. So what we do with these licenses, we say, okay, so if I have all these rights, then I'm going to put another license on top of it and give away those rights. So there is, you know, open source licenses work directly with the existing intellectual property system. So they do work together.
Okay. All right. Sounds good. So next question. Patents promote innovation. We've done that, have we?
Yes.
We're
yeah,
past
oh, yeah,
that one.
I think.
Oh, wrong way.
Yeah.
So, how about this one? Are professionals always better at designing things than users?
Of course, I think that the user understands their custom case. So where a standard design might not suffice for a particular situation, a particular user situation, the ability for a user to customize that technology towards their own needs is definitely a case where they're better at suiting their needs than the professionals who may put out standard designs, different variations, but not quite what the user needs.
I'll just say that if the professional is really good, and especially if that professional is a user as well, that professional will know really well how to design something. Now, a lot of users may have very little skill, so that particular user might not be really good at design. So it probably depends who the user or the professional is. Anything to add?
Yes, actually, Professor Van Hippel calls that type of user the really good one. He calls them lead users. They are users who
lead users.
Yes, who, without being professionals, are passionate and interested enough to actually develop alternative solutions. That's how the mountain bike was created, actually. There were no mountain bikes, users were unsatisfied, so they began modifying bikes, and now mountain bikes are the bicycle model that is the most successful in the world. And users develop them, not a corporation. And the reason is because users know what they want. And they will, some of them, those lead users, are actually willing to put in the time and the money to create what they want.
All right. So
I'd like to add in another thing. It's users sometimes may really know their need for a particular application, but professionals usually also know about the manufacturing and general design concepts that are really necessary for you to design something that can, for instance, be economically produced. So sometimes, even though a user may know their particular use case, the production and distribution case, they might know enough about.
Okay. Well said. Okay. How about making of hardware? Is it really expensive and time consuming, and that's why people prefer buying it to designing and making it? Well, making hardware is, if you don't have any idea of how to make something, absolutely, it would be very hard. So
why do you think open source is important despite that?
So open source can help us get those plans developed and make it much easier. So that's a way that we can reconcile this point.
I guess two categories we could assign here are, it's simply good to buy a technology, and that's where business models come in. And the flip side of things, some people prefer to engage themselves and find an enjoyable experience to learn while customizing or making hardware for themselves. So those are both sides of things.
I would add to that that preferring buying something as something that's less expensive, you have to watch out for that, because if you cannot fix it once it's broken, then that becomes really expensive and more time consuming than the thing you built yourself. So that's something definitely worth considering. Okay, open source technologies will benefit developing countries rather than developed countries. So is this stuff just for the developing world?
No, of course not. We see that open source has a scope that encompasses traditional, modern, and cutting-edge technologies. Open source as a R&D methodology encompasses all technologies in the world. So definitely, as applied to modern and cutting edge, we see today in developed countries, they too can apply.
Yeah, I mean, there's plenty of projects, for example, that are building open source robots, like Willow Garage, for example. There's all kinds of technologies being developed. Anything else to add to that? Developing countries.
Only, I mean, not directly related to open source, but a reflection of this. There was a study in 2010 about investment in research and development, and they found out that in the UK, users, amateurs, spent considerably more money in research and development of products for their own users than companies R&D did. So, and this is in the UK. So, I mean, I don't see why we're making a distinction between developing and developers. It's about anyone being able to modify, customize, and repair their devices. It applies to all of us.
Yeah, applies across the board. Okay, so actually we're running out of time on this session, so I'd like to thank you, Katarina and Yunso, once again, and thank you for participating in this and letting us speak up here. Okay, so thank you very much.
Thank you very much. Thank you.